Okay, so you have a problem from thermodynamics psychrometrics. So moist air sample has a dry bulb temperature and specific humidity is given, and we are asked to basically find out the relative humidity. So let's first discuss what is relative humidity. Relative humidity is the pressure of the water vapor present in the sample by the maximum pressure which the water vapor can have at that given temperature. So it's PB by PV sat at that temperature, and the specific humidity is mass of water vapor present by mass of air. So assuming that both are ideal, so I can write MV as basically MV can be written as, using, if both are ideal, so we can use PV by RT. So pressure of water vapor by volume of water vapor. Water vapor, let me denote by W. Pressure of water vapor by R, which is a gas constant for the water vapor, into the temperature. Now mass of air in the sample, air will have different pressure. Volume will be same because you are taking some unit volume of the sample. So both are ideal gas and both will occupy the same volume. The gas constant for air will be different, and temperature of the mixture will be at unit. So the mixture will be at thermal equilibrium. So every part of the mixture will be at the same temperature. So water vapor, which is again PV, okay, because I have denoted here PV. So PV, volume gets cancelled, so it's RA by RV into PA by PV by PA. So how do I now this universal gas constant of RA and RV. Now RA by RV, how do I represent RA by RV? Now RA by RV is basically universal gas constant by molecular weight of air. So that is for RA, and similarly for RV, which is a gas constant of vapor, it's a universal gas constant by molecular weight of water. So it's in the inverse ratio of molecular weight of water by molecular weight of air. Molecular weight of water is 18, and for air it is 28.93. So I can use that here. So that is 18 by 28.93 is for RA by RB, and PV I'm just writing PV. PA will be the total mixture pressure minus the vapor pressure. So this is my equation for omega, and 18 by 28.3 is usually written as 0.622. 0.622 it's written, and that is PV by P minus PV. So let's first use this equation, okay, and PV actually can be, now what about the total pressure? Now total pressure is given as is 90 kPa, and the saturation pressure, that is PV sat, which I am referring at 30 degrees, is 4.34. Okay, so let's combine this equation as well as our basic definition. So we get omega as 0.622, and this is so relative humidity into PV sat by the total pressure minus relative humidity into PV sat. Okay, so omega specific humidity is given as 11.5 grams, so 11.5 into 10 power minus 3, and this is 0.622. 5 is something we need to find. PV sat is given as 4.24 kPa, and total pressure is 90 minus 5 into 4.24 kPa. So in this equation the only unknown is phi, and once you find out phi from this, it will give as phi as 0.385. so that means it's 38.5%. So let's look at the answer. It's B. Now remember one thing here, guys, that relative humidity and the specific humidity, these two equations, most of the problems you get in these two equations, either one is given and the other is asked to find. So you have to basically use these two formulas, and the fact that both vapor and air are ideal. So we have basically derived the specific humidity in terms of relative humidity, and this derivation is something which is important, or you can always remember this direct formula so that life will be easy. So 38.5 is the answer. Thank you.